This lesson is going to be talking about how to write empirical formulas and molecular formulas when you're given the mass of each element. And to start off with, we'll talk about what we've been doing before with percent composition. So in class, we've worked on looking at nitrogen oxide and seeing how we can figure out how many grams there are of each of these, assuming there's 1 mole of nitrogen oxide. And so to start off with, we said that, well, we have 2 moles of nitrogen, thanks to that subscript, which means that I take my molar mass of being 14.01 grams of nitrogen and multiplying it by 2, so I have a total of 28.02 grams of nitrogen. And oxygen, I see that there's no subscript, so it's 1 mole of oxygen, which works out to be 16.00 grams of oxygen in 1 mole, and we have that mass being right here. Okay, so now the next question is, can we do the reverse? If I were given this mass, can I come up with this formula? And as you notice with how we did it, we first needed to get to moles, okay? So the key in all of this is to convert your mass into moles. So assuming you have a question where you say you have 28.02 grams of nitrogen and 16.00 grams of oxygen, what is the empirical formula? And remember, the empirical formula is simply a formula that shows the ratio. It doesn't actually show you how many atoms there are in the molecule, but the ratio of one element to the next, okay? So in this case, we have a ratio of twice the number of nitrogens as oxygens. So going back to our question, where you say you have a certain mass of each element, how is it that you get the empirical formula? We simply do the reverse. So we have 28.02 grams in nitrogen. I need to get it to moles first, so I know what that ratio is. I know that I have 14.01 grams of nitrogen in 1 mole of nitrogen. And that works out, if I cancel out, to be 2 moles nitrogen, okay? And for oxygen, I have 16.00 grams of oxygen. I need to figure out how many moles that is, 0.00 grams, and that is 16 grams for every 1 mole of oxygen, and that works out to be 1 mole of oxygen. So now I need to write it in my empirical formula. And for our purpose, it's not important how you write it. If you write the O first or the N first, I would sort of do it how I present it. If I present nitrogen first, then write it first. If I present oxygen second, then write it second. It's as simple as that. In college, you'll actually understand how to do the order of them. So now I have 2 moles of nitrogen, so I write N2 to represent 2 moles. And I have oxygen, just having 1 mole, so I leave it on its own. So that's the simple version of it. Now let's work on one that's maybe a little bit more difficult. The next one, what we can work on, is where I have let's try this one. I have 1.198 grams of carbon, and I have 0.302 grams of hydrogen. And for these, it's really important that you keep your significant figures. If you do not keep your significant figures, you're going to get answers that are not correct. So in this case, we're going to work with the smallest sig figs. We need to have at least 3 significant figures in our answer, all right? So just make sure you have that. So let's set it up. Remember, I need to get from grams to moles, and then from the moles, I need to look at my ratio. Okay, how much do I have compared to the other one? So let's set it up, 1.198 grams of carbon. And carbon, we remember, is 12.01 grams carbon for every 1 mole. Okay. And I'll set this one up, 0.302 grams of hydrogen. And we know that hydrogen is 1.01 gram hydrogen for 1 mole of hydrogen. And if I work through these calculations, which I will do right now. Let me stop it right now. So from that calculation, it looks like I have about this many moles of carbon. And in terms of hydrogen, I have 299 moles of hydrogen. And notice how many sig figs I have. Because I have 3 sig figs here, I need to make sure I have 3 here. Remember that first 0 doesn't count as a significant figure. And here I have 3 as well. So if I look at these numbers, and I can actually start seeing that this is pretty close to 0.1 mole of carbon. And this is pretty close to 0.3 moles of carbon. If I times it by 10, that would work out to be 1 mole of carbon. And if I times this by 10, to every 3 moles of hydrogen. So it works out to be CH3. Now, this is sort of something I do visually, where I sort of look at them, but you can actually do it more mathematically. And what you would do is you take the smallest number, here's your smallest number, and you divide it by all the other numbers. So here I have 299 moles hydrogen by 0.0998 moles of carbon. And what this is going to get us is our hydrogen to carbon mole ratio, okay? So that means that if I do my actual plug and chug, I put in on my calculator 2.99, we're working on this one, moles of hydrogen divided by 0.0998 and press enter. And you'll notice that my number works out to be that I have about 2.99 moles of hydrogen for every 1 mole of carbon. And that's pretty close. This is where we rounded to whole numbers to 3 moles of hydrogen to 1 mole of carbon. Okay? And we get our empirical formula right there. Let's try one more that might be a little bit more complicated, and then you can hopefully have all the skills you need to work on some of those problems that I gave you for homework. So we're going to start off where I have 4.151 grams of aluminum, and I have 3.692 grams of oxygen. I want to know what the empirical formula is. All right, so what I would suggest is stopping the video and then actually working through them with me. So I'm going to pause as well and give some of the answers in a couple minutes. Okay, so hopefully after you had stopped this video, you had set up your problem like this, where you've converted all your grams into moles. And we have here our ratio. And our ratio isn't that obvious, not like the last one where you're like, oh, it looks like it's kind of like a 1, and then this one looks like it's a 3. This one isn't as obvious. So we definitely want to set up the equation where we're going to create a ratio. And again, remember, you use the smallest number. Here's my smallest number. That goes on the bottom as the denominator, okay? This will be our 1 value. So I put 1539 moles. Keep in mind, look at how many sig figs I've used. You're going to get a different answer if you don't use that many sig figs. And I know how many to use. 1, 2, 3, 4, because that's what all of my values were given as. And then I place on the numerator the larger number, okay? And this will get a ratio of this here. So now once I do my division, I know I'm going to get an answer that tells me how many moles of oxygen there are in 1 mole of aluminum, okay? Because I'm dividing it by that, we have that become the volume of 1. And so if I look at this and do the division, it works out to be about, there are 1.5 moles of oxygen for every 1 mole of aluminum. And that's going to be impossible to write in an empirical formula because it's not a whole number. So we sort of think to ourselves, okay, how can I make this a whole number? I can make it a whole number if I multiply everything by 2. Okay, so I multiply everything by 2, which means that I have, and remember, because I said aluminum first in my part, I'm going to have 2 aluminums for every 3 oxygens. And there's my empirical formula.